Welcome to question 9 of the 2014 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 9 we have Sally who aims to walk her dog Mac most mornings. If the weather is pleasant, then the probability that she will walk Mac is 3/4. And if the weather is unpleasant, then the probability she will walk Mac is 1/3. And we're going to assume that pleasant weather on any morning is independent of pleasant weather on any other morning. For part A, we have in a particular week, the weather is pleasant on Monday morning, and it is unpleasant on Tuesday morning. And we are asked to find the probability that Sally walked Mac on at least one of these two mornings. So it might help to have a tree diagram set up where this is the outcomes on Monday, where she could have walked Mac or not walked Mac. And these are the outcomes on Tuesday, where she could walk or not walk Mac. So this was Monday and it was pleasant, and this is Tuesday when it was not pleasant. So the probability of walking Mac on the Monday when it was pleasant was 3/4. Meaning there was a 1 in 4 chance that she didn't walk Mac that day. And then on Tuesday when it was unpleasant, there was only a 1/3 chance that she walked Mac, or a 2/3 chance that she didn't walk Mac. And that's the same for the second set of branches down here. So the probability that Sally walks Mac on at least one of the two mornings is equal to the probability that she walks Mac on Monday but not on Tuesday, plus the probability that she doesn't walk Mac on Monday but walks him on Tuesday, plus the probability that she walks him on both days. So from our tree diagram we can see that that's the same as 3/4 multiplied by 2/3, plus the probability that she doesn't walk Mac on Monday is 1/4 times the probability that she walks Mac on the Tuesday, which is 1/3, plus the next result, which is multiplying along the walk then walk again branch, which is 3/4 times 1/3. So evaluating that, 3 times 2 is 6/12 for our first term, plus 1/12 for our second term, plus 3/12 for the next term. And that simply gives 6, 7, 8, 9, 10/12, which is equal to 5/6. So that is the probability that Sally walks Mac on at least one of these two mornings. And from the examiner's report we can see that 50% of students got both marks for that question, with 42% of students receiving 0 marks for the questions. And the examiner goes on to say that many students did not recognise the basic nature of the problem, and that a tree diagram or listing the sample space were the best options to answering this question. Another way that the question could have been answered is using 1 minus the probability of no walks occurring, which is shown on the screen as well. For part B of this question, we're told that in the month of April, the probability of pleasant weather in the morning was 5/8. For part I, we want to find the probability that on a particular morning in April, Sally walked her dog Mac. So to answer this question, we're going to start off with another tree diagram. The first outcome is whether it's pleasant or unpleasant on the morning, and then we consider whether or not Sally walked her dog Mac. So whether she walked the dog W or didn't walk the dog, which is W complement. So in the month of April, the probability of having pleasant weather was known to be 5/8, and it was independent of any other morning. So the probability of having pleasant weather is 5/8, which means the probability of having unpleasant weather is 3/8. And then our information in green still applies, that if it's pleasant, the probability she walks Mac is 3/4. So this is 3/4 and that's 1/4. And in orange, the probability of her walking Mac if it's unpleasant is 1/3. So the probability she doesn't walk Mac is 2/3. So the probability that Sally has walked her dog Mac on any morning in April is going to equal the two branches of the tree diagram that lead towards walking, which is going to be 5/8 times 3/4, plus the 3/8 branch multiplied by 1/3. So evaluating this, we get 5 times 3 is 15/32, plus 3 times 1 over 8 times 3, which is just plus 1/8. And now we can rewrite that as a common denominator. So we'd have 15 over 32 plus 4 over 32, which equals 19 over 32. So that is the probability that Sally walks Mac on any given morning in April. So from the examiner's report, we can see that 44% of students got full marks, and the examiner's report details a tree diagram approach and goes on to say that many students made a good attempt at this question. Most students correctly identified the required sum of two products, which was identifiable through the tree diagram. However, they made errors in the evaluation of the final fraction. For the second part of Part B, it says using your answer from Part B1 or otherwise, find the probability that on a particular morning in April, the weather was pleasant, given that Sally walked Mac that morning. So we can identify this as being conditional probability. So find the probability that on a particular morning in April, the weather was pleasant, given that she walked Mac. And that's going to equal the probability of the intersection, P intersecting W, divided by the condition, which is the probability of W. So from before, we can use our tree diagram to find the probability of P intersecting W, which is going to be 5 on 8 multiplied by 3 on 4. And then we divide that by the probability of W, which we just found to be 19 over 32. So this is going to equal 5 times 3 is 15 over 8 times 4 is 32. And instead of dividing by 19 over 32, we're going to multiply by the reciprocal, which is 32 over 19. So that fraction simplifies to be 15 out of 19. So that is the answer to this question. So from the examiner's report, we can see that 27% of students got full marks for this question, with many students being able to identify the conditional probability that existed within the question and use their answer from Part BI in the denominator of a fraction. However, some used an incorrect numerator in their working.